Hi, I am Bero. I'm one of the principal open source architects working on the Eclipse Foundation's Oniro project, an IoT operating system that can support multiple different kernels, such as Zephyr for Cortex-M microcontrollers and Linux for higher-end devices. In this talk, we are going to take a look at the GPIO APIs provided by these two kernels, and trying to find a way to make something work on both, with as much code reuse as possible. First, for the sake of context, let's take a quick look at what Oniro and the Dorlock blueprint are. Oniro is an Eclipse Foundation project focused on the development of a distributed operating system for consumer devices. It's completely open source and intended to run on all the devices you get in contact with. There's a big need to finally unify all the hundreds of thousands of different IoT device code bases out there. And as an important part of this project, we develop what we call blueprints. That is fully open source software and as open as possible hardware that can be used as a base solution for your own IoT projects. One of those blueprints is the Dorlock blueprint. Let's see what it does by taking a look at it in action. When we first power it up, the LED on the Arduino board starts flashing, which means it's ready to learn the pin that will be used in the future to undock. Obviously that pin is stored in non-volatile memory, so even if a burglar manages to reboot the system, that doesn't help him. Let's pick a pin that is really secure that nobody could possibly guess, like 1, 2, 3, 4. Since the system doesn't limit us in the length of the pin, we have to tell it we are done by pressing those two keys at the same time. Now the LED has stopped flashing. That means it's now operating in normal mode, waiting for someone to enter the correct pin. So if we enter something that's not the correct pin, nothing will happen. And if we enter the correct pin, 1, 2, 3, 4, our lock opens, we can open the door, and then it is automatically relocked. Of course, we can also change the pin. To do that, we enter the right pin to make sure it knows we are allowed to do it, and we press our two special keys again. Now the LED starts blinking again, and we are ready to enter the new pin. One special feature is that the pin can include multiple digits pressed at the same time. So let's still use 1, 2, 3, 4, but 2 and 3 pressed at the same time. 1, 2, 3, 4, and we are done. The LED stops flashing, and our old code of 1, 2, 3, 4 just won't work anymore. But 1, 2 and 3, 4 opens our log. So, as you have seen, we have a nice little log that works on an Arduino Nano 33 BLE running Zephyr, and that's exactly what we need it to be for a simple log like this. But what if we need it in a bigger context? Maybe on more powerful hardware with a more powerful OS, for example building a vending machine that unlocks several compartments containing the products based on user interaction. An Arduino and Zephyr will quickly get to the end of what they can do in a bigger context. So we could extend the hardware, keeping the Dorlock blueprint exactly as is, and then adding a Raspberry Pi or something for the user interface and control the Arduino over BLE or via GPIO wire or something like that. Or we could try to minimize hardware and integrate the Dorlock code into the Linux application. And being flexible enough to accomplish that is part of what Oniro is all about. So ideally we could just copy the C files to the Linux box and call into them. But the code is mostly calls to the GPIO API, there's not much else in there. And there's no standard for the GPIO API, there's no POSIX function for accessing GPIO. Even Linux has several different APIs. There's the deprecated sysfs GPIO API, the current dev GPIO chip API, and then there's libgpiod, and then if you look at the Git repository for libgpiod, there's a new version 2, which has another slightly changed API. And on the other hand, Zephyr has its own GPIO API, which obviously differs from all 4 of those. And since we already have the Zephyr code, let's see if we can make that run on Linux. Another option for maximum code exchange would be porting libgpiod to Zephyr, but probably having a compatibility layer on Linux makes more sense, because on Zephyr you need to save every kilobyte you can, while on Linux you probably have a bit more space to spare. The Zephyr GPIO API is rather simple and not too different in concept from Linux APIs. 100% compatibility is hard to achieve because Zephyr looks at device tree for device nodes, and that's not something we want to do on Linux. I mean, if nothing else, we might be using a distro kernel that doesn't have a custom device tree, so you don't want to get the user to enter stuff like the lock is controlled by a GPIO pin 4 into a device tree file on a Linux system. We might even be on a system that doesn't use device tree, for example an x86 box with ACPI. And also we may want some more flexibility like runtime configuration. Our GPIO ports might be on USB, or we might have 5 GPIO controllers and vary between the different GPIO controllers depending on the situation. We might have just a lot more GPIO controllers attached. So probably implementing the exact Zephyr API is not the right way to go. And a couple of if-defs or a small file with our specific definitions is not the end of the world. So my first thought was, let's do the obvious. We use device get binding DT alias as usual on Zephyr, and on Linux we use some other mechanism to open the device, where we could specify the GPIO device and the pin on that device. And after that everything is exactly the same as in Zephyr. So that would certainly be a workable solution. But then another thought crossed my mind. On a system capable of running Linux, we probably don't have to save every single byte of memory we can. We obviously shouldn't be wasteful, but we don't have to be quite as careful as we have to be in Zephyr. So what if we define DT alias to a function call that passes its argument as a string? Given this code snippet here, we just have to implement a GPIO pin function that looks up the correct GPIO device and pin for the name passed in a string. The C code using it can be the exact same as in Zephyr. We just need to implement a GPIO pin function that looks up the name for a device in the Zephyr device tree and maps it to a Linux GPIO dev device and pin. And that could even go as far as using a config file, a kind of a mini device tree. Of course, the drawback of this approach is that DT alias is not exactly a proper description of what happens on a Linux box, so the function is kind of misnamed, but that sounds like a good trade-off for increased compatibility and code exchange. The other downside is that it requires people to use DT alias instead of the older Zephyr APIs for looking up things in the device tree, but I think keeping code up to date with current Zephyr developments is a good idea anyway. For this to be really useful, we need to implement a few more things not directly related to the GPIO topic. There's some more functionality that pretty much every Zephyr application that deals with GPIO uses. For example, timers, and sleep, and other things that have a custom Zephyr API that is not available on anything else. So additional functions mapping those to a POSIX API would be a great help, and should be done soonish. So, where can you find it and start running your Zephyr GPIO code on Linux? Unfortunately, at the time of recording this, due to deadlines, this is just some started code on a local disk, but this may well have changed by the time of Frostum already, and if not, it will change shortly after. I'm currently somewhat busy doing other things, updating the toolchains to LLVM 14, but as soon as possible, the wrapper library will be released in the Dorlog repositories, and the Zephyr Dorlog code and everything you need to build the original blueprint is already there. So check out the Dolog blueprint repository. The link is on the slide. And sooner or later, hopefully sooner, the Linux version will appear there as well. If you have any questions, yes, I know, questions other than when can I have it, when will it appear, suggestions, or ideally if you're volunteering to help us, you can ask them now, or visit us at our virtual FOSDEM booth, and check out our website at oniroproject.org for more information about the blueprints and the other blueprints and the system in general. Thank you for your attention.
Q&A is starting now.
For your attention. Okay, looks like Q&A is starting. I don't see any questions yet. So let me preempt the obvious question. Is it out there already? Unfortunately, I didn't get around to committing it and cleaning it up. So it will be a few more days, but it will be in the Git repository soon.